right, so on Learning Suite today we're covering 2 chapters. Well, really chapter 11 is our main focus. Chapter 12 is just kind of a extra little blip on top of chapter 11. But to do that, we're going to be working with this workbook, isbn.xlsx. You can go ahead and download that and to get it ready. We'll use it here in a few minutes. But first, I want to talk in general about the principle that we'll be working with inside that workbook today. We'll just come to a brand new kind of blank sheet. We'll zoom in here a little bit. Now, let's turn the lights down. So let's pretend that it's the 1970s. Any of you here alive in the 1970s? I was alive in the 1970s. The 1970s were fabulous. You know, I was only like 6, but bell-bottom pants, polyester, great time. I had hair. Computers are really now just getting to where businesses are going. We got to computerize. If we're going to compete, we got to computerize. Anyone know what the original worldwide estimate for the total demand of computers was that IBM made? IBM's going, these computers look like they might be important for business. We're going to estimate the total worldwide demand for computers. They did this in like the 1950s. Might have been the 60s. Anyone know what it was? If you happen to know, take a guess. Anyone, throw a number out. Yeah, 5. Let's say, 5 computers ought to do it for the whole world. There's someone here who's probably walking around carrying 5 computers with them. They got a phone, they got a laptop, they may have a tablet, they got a watch and a calculator. Anyone? You got 5 computers on you? Not today. But that's not unheard of. So anyway, they were wrong about that. So it's the 1970s, and everyone's going, we've got to compute. Now, let's suppose that you're running a bank, and you've got computers. Now, in the 1970s, computers are not very powerful. And telecom is really slow. So here's what we're going to do. We're going to put a computer in place. The teller is going to work with the computer. And let's say we needed to design a system that will allow us to just deposit a check. What are we going to do? What information are we going to need to collect to be able to deposit that check? Design the interface with me. Folks, you don't have a mouse. It's 1975. You don't have a mouse. There's no mouse. It's just characters. What information are you going to need to be able to deposit that check? Yeah, go ahead.
Like the routing number and account number?
Well, you need an account number. Okay, so let's see. Maybe let's just think about cash deposits. Well, let's not worry about checks. It's cash deposit. Okay, we're going to need some account number. You're going to deposit some money into the bank. We got to know which account you're going to deposit it in. So account number, and I'll do something to make it look like we're entering some field here. So I'll put like a heavy border around the thick outside border. Okay. What else do we need? Any thoughts?
Amount.
An amount. And thick outside border there too. Anything else we need?
Time of the deposit.
Well, the date. This is the great thing about computers. The computer can record the date. We don't have to enter that in. It knows what day it is. That's good. One of the things computers can do pretty early on is keep track of what date it is.
Name on the check? Who it's written out to?
Okay, so actually I adjusted. We're just doing a cash deposit. Check deposit, well, a little more complicated. Let's just go simple.
The denomination of cash?
Okay, so depending on what all records we need to know, maybe we need to know how much is in coin, how much is in paper money or whatever. Forget that. I think we got enough here to work with for the example that I'm after. So we're going really simple. Okay. So, so somehow we've got an amount. We're going to type in some amount, $100, we're depositing it. Now, let's put the account number. Here's some account number.
Is that your account number?
That's my account number. I want to deposit money in my account to be my cash. Okay, so talk to me now about the risks of using this newfangled computer to record the deposit. Okay, something could be typed wrong. So we've got a problem. The amount could be entered wrong. You might have the decimal place in the wrong point. But what's another thing that could go wrong? The account go wrong. All right, let's solve that problem. Let's not worry about the dollar amount right now, but let's solve the account number problem. What are we going to do to make sure that the account number is entered correctly? Give me some thoughts. Go ahead.
Can we match it with the name they know?
Okay, so what you're suggesting is let's take whatever number they entered in, let's make a request to the database, wherever that is, and look up what that value is and bring back the name and display that on the screen for the user to see. We could do that. Trouble is, that's going to take 30, maybe 40 seconds to do. And so that's a really costly choice to make sure the account number is entered correctly. Now, it may be that the person walks up and doesn't know their account number, and we need to have that process to go look that account number up. But if they're just going to give us the account number, we just want the leanest, most efficient way that we can make sure the account number is entered correctly. Go ahead.
There's a number of digits for the name of the bank.
Okay, so now here's what you're saying is that we could do some validation just by looking at it. So, let's say our account numbers like this, they're 6 digits. And so I type this one in, immediately I can know it's not a valid account number. It's not the right length. Okay, so that's good. What else? Now, so just getting it the right length is something, but it's not enough. So what else can we do? Any thoughts? Go ahead.
Required input it twice, so that the person has to look at it twice, and that way if it's wrong.
Okay, so maybe you have to type it in twice. That would be pretty good if it's a slip of the finger that makes it.
Yeah.
But part of the problem could be is that when I read it, I can do the transition before it hits the brain. Then typing it twice doesn't help. So that would help a class of problem, but it's not going to get us there. Go ahead.
I know sometimes they'll make the first 3 digits the same for every account number. So then if you only have to validate half the number to make sure that it's accurate.
Okay, so you're saying all the numbers in our bank are going to start with the first 3 digits the same. It only gives us 1,000 accounts, but maybe we could do add another digit or something. Okay, so that reduces the spam. I'm not sure what that does for us. It makes us type a little more. We still have to validate the number of accounts that we've got. Go ahead.
So if we're going to restrict it to 6 characters, we could also say it has to be a number and not a letter.
Okay, can't type in letters. That'd be pretty good. We can look at that. We can look at each character, make sure that it's numeric.
You can put a verification number at the end that is calculated based on the other ones.
Yes, okay. What you just described is something that's referred to as a check digit. That is exactly what we did. Let's talk about that process because we're going to be using that for our example here today in class. Here's the idea. Let's just do it this way. Let's just say that we were going to, I'll show you kind of what our first stab at this. We've gotten better at this over the years. But we could do this. We could say, listen, let's sum up these digits. What would that be? That would be 10, 21, 26, 27, 28. So the sum of all those digits is 28. So now what we'll do is we'll say, listen, it takes 6 characters to uniquely identify the account, but now the account number is going to have 2 more digits placed on the end to indicate. So now the account number is more than just a unique identifier for the account. The account number is the identifier plus something else that lets us to do a little bit of arithmetic on what was typed in to be sure that it was done right. So now, that's the whole account number I have to type in. Now the computer, without making any telecommunications call, could just do some math really quickly. Check to make sure that it's, we've got 8 digits now. Check to make sure that it's 8 digits. Check to make sure that they're all numeric, and then add up the first 6 and see if it equals the last 2. What do you think? Is this gonna really reduce the likelihood of getting this thing mistyped? Yeah, whether I read it wrong or whether I type it wrong, this is pretty good. It's got one severe flaw we'll talk about in just a second. But this is really pretty good because if I make a mistake in the first 6, I have to make a compensating mistake in the last 2. I'm going to make 2 mistakes and they've got to balance each other out for this to sneak past. Yeah, go ahead.
Still doesn't compute to all these bank routing numbers add up to 28, or is that just unique to this one?
Well, that's to this particular one. So we had another number. So let's look at what the whole account number would be for this account number. So let's say instead of 2, it ends with a 5. So now, if that's the unique part of the account number, if that's what uniquely identifies the account, I'm going to build
filled in the checksum, was what it's called. And so I would sum up all these digits. So I got 5, 5, 5, 15, 21, 22, 23, 31. So then I would add, to get the account number, I would put a 31 on the end, and so now that is the account number. So now when someone enters in a number that they think is an account number, what we can do is we can add up the first digits, the first 6 digits, get a sum, and see if that equals the last 2 digits. And then if it does, we say, okay, we think you typed it right. Okay? What's one of the most common mistakes that you'll make when you're typing something?
Type 2 digits out of order. Say
A transposition of 2 digits. So does this help us? You know, if what would happen if I transpose the 5 and the 2 on this?
Nothing. It equals the same.
Yeah, it would still give me a valid check digit. I mean, the checksum would still match. And so this was kind of like the first baby step in this direction. And, of course, the algorithm is really simple. Sum the numbers and then compare. So then the idea was, what if we could come up with a slightly more complex algorithm that would allow us to, this is the characteristics we'd like to have. Number one, if any single digit is just wrong, we want to be able to know that. If any 2 digits are transposed, if any 2 sequential digits are transposed, we want to be able to know that, and we want to be able to do that with only supplying 1 additional digit to have to type. So instead of 2 digits, we want to do it with 1. That's really what we're after. In fact, when we have an algorithm like that, it's referred to as a check digit. Well, at least that last number is referred to as a check digit. So let's say we could get by without the 28, just the 8. Now, the algorithm is going to be more complicated, but if we could achieve those things, any 1 digit being typed wrong, any 2 sequential digits being transposed, and be able to know that's got to produce a different check digit, that would be fabulous. And that's what we're going to do today. So we're going to write a function that will validate a 10-digit ISBN, International Standard Book Number. And we'll talk about the algorithm for that in just a second. But while we're here, I just have to kind of mention this. It turns out, how many of you are familiar with Frank Abagnale Jr.? Anyone know who that is? Who's Frank Abagnale Jr.?
Catch me if you can guy, check fraud guy.
Yeah, so he's the check. He was one of the best guys at making fraudulent checks that the FBI had ever encountered. This happened in the 1970s, 1980s, I'm not sure. In his autobiography, he even claims to have frauded his way onto the faculty of Brigham Young University. The university has no record of that, incidentally, so I'm not sure what happened to those records, if there were records. But anyway. So, his very first financial fraud, he actually cheated money out of his dad's credit card. That's how he actually got started. But the first time that he went to directly to kind of financial instrument fraud was this. He's going to his bank and he realizes that they have counter deposit slips. What's a counter deposit slip? It's a deposit slip that just sits out there on the counter. And someone can walk up, pick up a deposit slip, write in your account number, and fill this thing out and go make a deposit. Well, he realized that if the person wrote in the account number, the teller would come to the interface like this, key in the account number, make the deposit, and move on. But, if the account number was blank, the person would write their name on the account, and the teller would look it up and then get the account number, type it in, and move forward. So he took a stack of these deposit slips back to his house, and with his typewriter typed in his account number. Left the rest blank, took them back and put them on the counter at the bank. So when Edna deposited her paycheck, she would come in, as she always did, she would write her name onto the deposit slip, deposit her a check. The teller would look at it, key in the number, deposit it into his account, and then about a week and a half later, he cleared the account out and disappeared. So there are other problems that you have. So some of the things you suggested here, such as actually, once the number goes in, bringing the name back so that the teller could verify that it really is the name that matches there. But in these early systems, it didn't do that. If you wanted to convert a name to a number, it was a separate screen. You'd go look it up, bring the number in, put it in, and then make the deposit. So you'd never have any cue. The teller never had any cue that they were making the deposit to the wrong number. All right, let's take a look then on sheet 1 of the ISBN worksheet. This is the check digit algorithm for a 10-digit ISBN. So here is a 10-digit ISBN. 1, 2, 3, 4, 5, 6, 7, 8, 9, X. We take, so these are a little bit, not quite lined up right. Sorry about that. So we take the first number, 1, we multiply it by 10. Second number, multiply it by 9. Third number, multiply it by 8. Up, 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 up. And then we sum those up. So, right, multiply those across, that's 10. Multiply these across, that's 18. You sum all those up, that gives you 210. That's the first step. Second step is we take that number, mod 11. What does that mean, mod 11? Divide by 11, what's the remainder? So in this case, 210 mod 11 is equal to 1. I then say I'm going to take 11 minus 1, and then that's going to be my check digit. So here's the problem. I've got, what are the possible values here for the end of this result? 0 through 10. How many different characters is that? That's 11 characters. So when I take 11 minus 0 through 10, let's see, something's not right here. I think I might have represented this algorithm a little bit wrong. We'll probably implement it this way, and I'll check to see what I've gotten wrong here. The point is, I'm going to end up with 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 digits. So yeah, my possible answers here is going to be 0 through 10. What I have here. Can't be 11, well, it could be 11. But it couldn't be.
It can't be 11. Because if it's 11, it's 1 interval.
No, up here I can't get 11.
Yeah.
If we get 11 minus 0, this could still result in 11. I got to verify this. I think I might have written this down wrong a little bit. Anyway, the point is there are 11 possible values for my check digit, and ultimately they're going to be 0 through 10. So I may not have shown it correctly here. And so, does anyone have a book here that has a 10-digit ISBN? It's now a little bit antiquated. The current standard is for 13 digits. Anyone have a book that's got a 10-digit ISBN? Sometimes they have both, like 13-digit, 10-digit. You got it here? Thank you. So yeah, you've got 1, 2, 3, 4, 5. Anyway, so here it is. Can you see that? 10-digit ISBN. You're going to end up, I'm not even sure why I wanted to look at one. Thank you. Well, you might end up with a 5 as a check digit, a 6 as a check digit, a 0 as a check digit. But what are you going to do if you got a 10 as a check digit? You really want to be able to represent this with one character. How do you say 10 with one character? Yeah, X. Roman numeral 10 is X. And so, in the case when this algorithm produces 10 as the result, then the check digit is X. Otherwise, it's just the result of the algorithm. Just pause for a second and see what's going on. Come over here and just look up ISBN. National Standard Book Number. It's 10-digit calculation. Take that mod 11. Mod 11. What's that?
They're taking Model 11 twice.
They do it twice.
Taking the answer Model 11 and then doing that Model 11.
No, I think they're giving us various steps here, kind of compressing it into one. 13-digit ISBN, 10-digit conversion. All right. Anyway. It's not so important that we get the calculation right, is that we see the function. I mean, we'd like to have it right. Let's go ahead and implement this, and then it'll probably just be a small change, which you can take. chance to take a look at it. So let's go ahead and find for ourselves. Actually, there's this one right over here on ISBN. It shows us the intermediate steps. Let's work with this one, and maybe the error that I have will kind of bring itself up. So here is the ISBN that I want to work with. I'm just going to bring it over here into Excel. Maybe I'll just put it right here. It should be 9 digits, and it said the calculation that I was looking for was 2. Now, because this starts with a 0, I better put a single quote in front of this to keep that 0 from disappearing. So there's my ISBN. You have to make that a little bigger. All right. So we now have kind of 2 different algorithms that we can work with. Let's go ahead and work with this one, since we know what this one is supposed to be for sure. So let's begin then by understanding what we're creating here, and that is a function. We're going to create what's called a function procedure. So open up your code editor, insert a brand new module, and we're going to create a function now. So far, every time we've started, we've said sub. Sub, we give it some name, is valid ISBN. Is valid ISBN. Okay, and so this gives us a procedure. This gives us a sub-procedure, but I don't want a sub-procedure. I want a function procedure. Someone, tell me the difference between a sub-procedure and a function procedure. Go ahead.
Function returns value.
Yeah, function procedure and a sub-procedure, they're almost identical to each other. The only difference is that when the function procedure is done, running whatever block of code we have here, it sends back a value to wherever it was called from. And there are lots of different places we can call this function from. So let's take a look.
Is there a difference in like the scope?
Yeah. So the question is there a difference between where you might be able to access one from the other? And the answer is, the broad answer to that is no. Let's check one thing here. One thing I'm not sure is if I have a function with no arguments, which we'll talk about in just a second, does it show up here as a macro? It does not. So functions, regardless of anything else, you can never run them from the interface like you would a macro that's a sub-procedure. Other than that, the scope should be the same.
Sorry, are you recording?
I think I am. The little box went away, but it says the recorder is recording. Thank you. Don't ever feel bad to ask that question. I definitely want to make sure that we're recording. Okay, so first, because a function returns a value, there has to be some way for us to tell the function what value to return. Now, this function, I just want to return true or false. Ultimately, I'm going to give it one ISBN, one candidate ISBN, and then I'm going to want it to look at it and then say, yeah, this is a valid, it's a well-formed ISBN. Is it possible to have a well-formed ISBN that is not a valid ISBN? Yeah. There's lots of ISBNs that have not yet been issued yet. They're not bound onto any book. We just want to know, is it well-formed? That's the idea. It's going to be a well-formed ISBN. And so let's just see what we have to do. Well, let's go ahead and give this function a type. So let's begin by telling it what it's going to return. Is it going to return a string? Is it going to return a number, an integer, a byte, a long integer, single precision floating point number, what? Boolean. This one's going to be true or false, so the type is Boolean. So just as if I was creating a variable, dim x as Boolean, up here I can say, give the function name as Boolean. I give the type the same way I give a variable a type. So function is valid ISBN, and then over here I say as Boolean. Now this is going to return true or false. It'd be good if I tell it which one to return. But if I don't bother to tell it, it's going to return one of them. Go ahead.
I thought function returned true or false regardless of whether it's a Boolean or not.
No, function can return any valid data type. So a function can return a string, it can return an integer. Just like if we think over here, if we look at a particular function here, in fact we got one here, sum. Here's a function built into Excel. It's returning an integer. Sum could return a floating point number as well. So we got to tell it which type to return. So folks, now that I've declared this function, I can come over here into a cell somewhere and I can call it from right here. Is valid ISBN, opening and closing parentheses, hit enter, and it brings back one of those, true or false. Why did it pick false? Every data type has a default value. For Boolean, the default is false. For all numeric types, the default is 0. For the string type, the default is an empty string. And so, you moved your lips exactly the same as I said that. That's amazing. And so if I don't ever tell this Boolean function what to return, it's going to return false. There are only two things that a Boolean function could return. If I forget to assign it, it's going to pick one. It's going to pick its default value. So how do I make it return true? This is how I make it return true, or any specific value. It's a little bit weird. VB, kind of Visual Basic is the only environment I know that does it this way. We set the name of the function equal to the value we want to return. So now, if I come over here and refresh this worksheet, the result of that function changes to true. I can call function procedures from inside of another VBA code, or down here in the immediate window. I can just say print, the result of is valid ISBN. And that prints true. If this was false, it would print false. So whether I'm calling it from inside a cell, from the immediate window, from some other sub-procedure, you can just think of it. And you'll see that when I say it returns the value to where it was called from, this call to a function returns a value. This function gets evaluated to either true or false, in this case false. And so I can think of it as saying, okay, here's a statement I'm calling that function. That function goes and does whatever it does. And now instead of printing the function here, it's going to print the result of the function. And so that behaves exactly the same thing, the way if I was just to substitute the return value from the function right where the call to the function was made. Does that make sense? Call that function. As far as the interpreter is going, I've got to figure out what this evaluates to. It goes and runs this function with, aha, that evaluates the false. And it just replaces the call with the result of the function and moves on. So this idea right here, the value is going to come back and kind of take the place of the call of the function, that's a new idea. How many of you are going, I totally get it, let's move on? How many of you are going, what the heck is going on here today? So you must be, if you're not volunteering for either of those, you're somewhere between those two. Okay. So, yeah.
How do we refresh the sheet?
Oh, to refresh this sheet, F9 is the recalculate.
Oh.
All right. Now, typically, a function is going to need something to operate on. In this case, we've got to send it a value. And we need some way to get that value into the function. Here's how we do it. So let's just suppose, I'm going to take this in a couple of steps to get there. Let's say I need a variable to hold that value that I'm going to call the candidate ISBN. And I'll just call it candidate, C-A-N-D-I-D-E, as a string. And then I would need some way to get that value. Now, if we didn't know what we're about to teach you, one way to get that would be, as I've got the variable here, I can just say candidate equals active cell.value. So this is one way to get a value into a variable. Declare the variable, and then have some other statement that says that variable is going to take on a value. We'll read it off the sheet and bring it in. Here's the trouble. I mean, this isn't going to work for us because, I might have 12 of these things, and I don't care what the active cell is when you recalculate. I want this one to look at that particular cell, a different one to look over here at this cell to pull the value. And so, this approach isn't going to work. Fortunately, there's a way designed just for handling this idea, that I have a function, I want to send a value into it, and have it do some calculations with it, and send me a value back. Here's the trick. Instead of declaring the variable here, I'm going to declare the variable here. Delete it from there. These parentheses are for, by the way. Inside these parentheses, I'm going to declare that variable. Now, it turns out that the only thing I'm allowed to do inside those variables, inside those parentheses, is declare a variable. I can do more. There's only one thing I can do in those parentheses, and that's declare a variable. Because it's the only thing I can do, this word dim is not necessary. In fact, it's not allowed. So I'm going to get rid of the word dim, and now I have set up what's referred to as a parameter. It is a variable. In every sense of the word, it's a variable. What's a variable? Tell me what a variable is. It's kind of two parts to a variable. It's a location in memory with a name. With a name, yeah. It's going to have a specific type. That's true. Maybe there's three things. It's going to have a particular type. It's going to be a location in memory, and it's going to have a name. This is a particular type. It's going to be a location in memory, and it's got a name. But because it's declared inside the parentheses here where I'm making the function, it's a special kind of variable called a parameter. Parameters get their value, although I can do something like this. It's a variable, after all, I can do that. Instead, I'm going to give it its value when the function is called. So down here, I'm going to pass it. I'll just go ahead and copy this out of Excel to get the value. I'm going to pass it that value. This function, I can do a debug.print along the way here. Debug.print, candidate. And so now this should print two things. When I execute this line, it's going to print the result of this function. But on the way to calculating the result of this function, it's going to print whatever the value of candidate is. So it should print this number, and then it should print false. So we get a both. This print statement is what's printing the false. This print statement is what's printing the number. Do we see it?
Yep.
Go ahead.
So if we have the function is valid at ISBN more than once on the Excel sheet, under this code, it would print like every instance where that function appears.
Yes. In fact, let's just go ahead and see what happens. I'm going to clear this out. I'll leave the call there, but I'll clear these other things out. I'm going to come here and cause this to be recalculated. I'll just hit F9 to recalculate this. Oh, it's because this doesn't actually refer to that cell. I don't know what to do with that value. So I'm going to put here, reference to that cell. So now I've modified my formula to give it a value to work on. That has called that function to find out that it's false, and that should have printed in my immediate window. Let's see if it did. There it is. It printed that value in the window. If I were to refresh this multiple times, then it should print it each time. Be smart enough to realize that nothing has changed, and so just hitting F9 isn't enough. Come up here, edit this cell, hit enter, and that will cause it to recalculate and print that number. Is there a question over here? Okay. So now our task is, incidentally, folks, plot spoiler. Let's take a look at the next project. We look at our next project. So here's a project called ISBN Validator. We are today writing a 10-digit ISBN validator. The project is for you to write a 13-digit ISBN validator. It's a different algorithm, but the principle is the same. So the stuff we're doing today is going to directly affect this project, this next project that's going to be due on the 10th. Okay. Question?
I thought our next project was the road color switcher.
That's the next homework assignment.
Oh, thanks.
We got a couple homework assignments coming up, and then the project. You're interested in a project and a homework assignment? Homework assignment, it's supposed to be pretty easy. You can work together on it. As long as your fingers are doing the typing, you're okay. Project, big difference is a lot harder. Closed neighbor. Do it yourself. Talk to the TA. Talk to me. Talk to God. Your bishop, by the way, is off limits. Don't talk to your bishop about it. Your bishop could be like some programming genius. He's off limits. Alrighty then. Okay, so we got to do step 1 of the algorithm over here. So step 1 is, well, the real step, the very baby step 1, is to take our first digit, whatever it is, passed in, and multiply it by 10. So let's just do that, and we'll kind of look for a more general way. I'm going to quit printing this out. That print statement. And let's just say I'm going to need some variable here to kind of keep track of this interim step. So let me just dim something called checksum. This is me adding up the first step, CHECKSUM, as an integer. All right, so the very first thing I'm going to do is I'm going to take the leftmost character off of my candidate. How do I do that? Left of candidate, one character, and I want to multiply that by 10. Now, after I do that calculation, I'm going to put the values somewhere. I'm going to put it here. Checksum equals. What's my next step? The second character times 9. And then I've got to add that into my checksum. I've got that one, I'm going to add in this one, add in this one, add in this one. So I'm going to say, all right, checksum is going to equal something else now. Checksum is going to equal what it used to be plus something times 9. How do I get to that second character? What's that? All right, now if I take left 2, left of candidate, comma 2, that's going to give me the left 2 characters. So in this case, it would be tough because it would actually give me the correct calculation, but only because the first one's a 0. So left 3, left 4, that's going to give me that number of characters. So that doesn't work. So I could use mid to do it, or I could take the left 2 characters and then of that take the right 1 character. Let's use mid. We'll use mid of candidates starting at the second character and taking 1 character. Looks pretty good.
Can I make this loop through so you don't have to type?
Oh, we're not going to learn about loops until next week. But we will. We'll take a peek. We'll do this in the loop here in just a second. Yeah, you're right. This is only 10. It's not too bad. Write out 10 lines to do this. A loop would be better. But I want to get one more line in here, and then let's talk about putting this into a loop. So the next one is going to be start with the third character, take 1 character, and multiply it by 8. This looks like a pretty good candidate. Let's do one more. The fourth character, multiply it by 7. Anytime I see myself doing this, I'm making a series of statements that are all really pretty similar to each other. I've just got some little numeric differences in here, I should say to myself, oh boy, that's going to be a lot of work to keep typing all this stuff. I'd be better off with a loop. Got a whole chapter on loops coming up. We're going to take a peek at a loop today called a for loop. The for loop was designed for handling just this problem. In fact, before we get there, let's ask ourselves, could we modify this line to look more similar to these other lines? What do you think? Yeah, it could look exactly the same, right? Mid of candidate starting at 1 and taking 1. And in fact, could we put the checksum in it as well? Are we able to do that as well? What's the default value for checksum? What's it going to start with before I put anything else into it? It starts with 0. So the first time I hit this, if I say it's going to get a new value, what's it going to be? 0 plus this. You know, the number 0 has another name besides 0. It's called the additive identity, which means you take any number, you add 0 to it, it doesn't change the number. So because we're starting off with the additive identity, we can do this, it doesn't hurt anything. It doesn't change the value that we've got. That's going to put us a value here. The next one, we're now going to kind of accumulate these. So now for sure, I've got 4 lines that are all exactly the same, except for a little bit, these numbers change, but they change in a really predictable way. That's what the for loop was designed for. Let's take a look at the for loop. To do a for loop, I need to have a control variable that's an integer, that's some integer type. It could be a byte, actually some kind of numeric. Any numeric type I think will do the trick. So let me just dim a variable called x. I'll declare it as a byte. BYU. Declare it as a byte. Integer just kind of rolls off the tongue here, but bytes should be plenty for what we're doing. So now, let's just take a look at what this loop does. Here's the syntax. For, and then I give it the name of the variable, x. I give that variable a starting value, and then I give the variable an ending value. For x equals 1, 2, 9. Next. This loop is going to execute 9 times. But the really important part here is that the loop itself is going to change the value of x for each iteration of the loop. So if I just say print x, I'm going to put a breakpoint right here. I'm going to call this function, and now I'm going to step. I'm just going to use F8 to step through this. The first time x is printed, the value is 1 because this x equals 1 here says start at 1. And so when I execute that line with F8, it'll print 1. This statement here next adds 1 onto the control variable. And so now, right now, x is 1, but as soon as next gets executed, x is 2. So now when it prints this line, it prints 2. The next changes it up to 3, 4, 5, 6, 7, 8. Now, as soon as I hit next, it's going to be 9. Where do we go at this point? We continue in the loop. The loop is going to execute until the control variable is larger than the last value I put here. So right now, x is 9. I will print with 9. F8 prints that. Here's the 9. I hit the next. Next is going to add 1 onto it. And now I'm out of the loop. Well, what happens if I print x right now? What if I just come down here and say print x? Now it's 10. X really did go out of bounds. That's how I got out of the loop, was the x went above the number that I specified here as the end. We're going to learn about some other specific things that the for loop can do, but this is all we need for today. We've got a whole chapter. Okay, so this is now going to give us the ability to execute one line of code multiple times with a different value for x. Now, if I think about taking these 4, and ultimately we would need 9 of these lines, if I think about taking these 4 lines and putting one of them up here in my loop, what changes do I have to make? Let me copy the first line here and put it in. All right. Now, if I just do this, it's going to run exactly the same line 9 times. That's no good. I need to make it so the first time through this loop, it does this line, The second time through the loop, it does this line, third time, and so forth. Go ahead.
Change the first one to the variable x.
Yes, very good.
And then
Don't say anything else yet. I'll let you fill in the rest of it. So I make this x. So think about it. The first time this runs, that x is going to be a 1. It'll be just like doing this. The next time it runs, it'll be a 2, just like doing this. The next time, it's like doing this. Okay, so now I've taken care of that part that's going to change as it goes. Go ahead with the second thing I have to do.
And then instead of 10, put 11 minus x.
So now I'll put some other argument here, 11 minus x. Now, turns out multiplication happens before subtraction, and so I want to make sure that subtraction happens first by putting it in parentheses. And so now, if I think about this, think about both of these expressions through the first time through this loop, x is 1, and so that's going to be a 1, that's going to be a 1, so this whole part is going to be a 10. Yeah, 1, 10. Second time through the loop, x is 2, that'll be a 2, this will be a 9. And that's going to go right down and do the whole thing. That's fabulous. So now I can get rid of this. I don't have to do all 9 of them. I can do it just with these three lines. I'm going to put a breakpoint here. No, the breakpoint where it is. And I'm going to show you another little debugging tool here. It won't be all that helpful for you to see on the screen because it's going to be teeny tiny. But if I view my locals window, the locals window, so I can get it to dock somewhere reasonable. There we go. The locals window will show the value of all my locally declared variables. So I've got 2 variables declared here. Actually, probably there's more than that. Anyway, it shows all of my variables that are available at the particular location that I am. So now if I run this by calling the function from here, it'll run to this point right here. Now I haven't changed the value of checksum. I haven't changed the value of x. I should see those both right here. Yeah, here's checksum, it's 0. Here's x, it's 0. And as I go through this, I'll execute this line, and it should make x1, which it does. When I run this, it should do the first calculation. Now, unfortunately, the first calculation, or first character, is 0. And so it's still going to be 0. But as I get to the second one, it should give me a value there for checksum. And since I'm accumulating this value, I'm saying it equals what it used to be plus something. It should never go lower. It might stay the same as I go through this, but it should never go lower. So 693, 117, that's looking pretty good. It's going bigger. And it gets up here to 130. So as I go through that whole part of the algorithm, I produce 130. Let's go back to Wikipedia and take a look. Is it showing me the interim steps here? Well, that's not a lot.
It says 130.
Well, it says it somewhere?
Right.
Bottom
Next
bottom
down.
left, it's the more.
Yeah, okay. Oh, down here, yeah, showing it in here. We should edit this page and make this calculation a little more clear. Well, I shouldn't edit it until I actually understand that. Okay, so we've got the first thing taken care of. The first thing was to sum up values of those digits. Let's go ahead and try it with this number as well. Yes, go ahead.
So I may have missed this earlier, but when I try to run my function, it brings up a macro name box.
Aha! Got me right with you. Okay, so if you come here, you're just here on the function, you say, hey, I want to run this function, push play, it says, all right, what function do you want to run? And there's none to choose from. Because these are the macros that you have available. And function procedures are not macros. Some sub-procedures aren't macros. So to be a macro, you have to be a sub-procedure with no parameters. You've just got to be able to say, run this. Because I can't, there's no way for me to supply a value from this window. All I can say is run this code. And so the only thing I get listed here are sub-procedures with no arguments. Actually, they're public sub-procedures with no arguments. We'll talk about the public-private thing later. So to run this, I have to do something that can run this and supply a value to the parameter. why I'm doing that is I'm just saying in the immediate window, I'm saying print the result of the function when I pass it this value. And I'm hitting enter on that line.
And that you're just playing that, and that gives you your local window values.
Oh, yeah, actually, to be able to see these locals, I have to view them. I say view locals window. That brings that window up. And then because I've got a breakpoint inside the function, when it tries to run, it gets to that point and stops. I mean, it would actually display the locals window when it runs, but it happens so fast you don't even see it flicker. So we kind of have it paused here. So now if I hit F8 to kind of walk through this, I can watch the values change as we go. Still, no matter what I do, it prints false. Let's go ahead and try it here with this X. Anyone nervous that this X is going to be a problem for us? Hit F8 to hit F5. Run that line, F8. Going through, the values are changing, it's feeling pretty good, it's looking pretty good. Works okay. How come it's not a problem? Yeah, I'm only going to the first 9. The idea here is I'm going to look at the first 9 digits, and then I'm going to check to see if the result of whatever algorithm I'm applying to those 9 digits produces the correct value on the end. Can I call this function from a cell? What do you think, folks? Yeah, in fact, we already did. It's right over here. Yeah, that's one of the great things is that you can make, folks, how many of you have ever written these really huge, long formulas in a cell? Are those readable? Yeah, once you've got that written, you go away just like to get a drink, and you come back, or what was I thinking? I have no idea what this means. Am I right about that? Yeah. So you could take that, and you could build that logic into a function that then you can annotate, you can spread it out and do whatever you want with it, and then you say, well, I got to bring in these 12 values, and you line them all up, do all the calculations here, and then it would just dump that into this stuff. So yeah, that's what Excel refers to as a user-defined function, and that's what we're creating here. All right. So far, so good. What's the next thing that I want to do here? Oh, so now I just want to take the result of that mod 11 and get the result. I'm kind of done with checksum by now. I kind of keep working with the checksum value, so I'll just say checksum equals that calculation I have so far mod 11. We'll go ahead and run it to that point. We'll run through that whole loop first. We'll see what checksum is. At this point, checksum is 130. I'll execute this line with F8. Now checksum has gone to 9. Get that interim step over here at Wikipedia. 11 minus that 11 mod 11. They are taking it mod 11 twice, aren't they? So then I've got 11 minus 9. So I'm now taking 11 minus that value.
Do you need to do? It looked like it was like 11 minus the mod. Did we see that part?
11 minus the mod of that. Okay, so yeah.
Not that.
So I've got the mod of this. So let's do that in the next step. Very good. So now we'll just keep kind of playing with checksum. Equals 11 minus what we already calculated. Actually, we can do it right up here. Let's just do it in this one line. 11 minus that whole thing. Minus that. We're going to take it that thing mod 11 again. Could do it on the same line, but I'll do it on one more line. So checksum equals checksum mod 11. checksum is 2, is that what the calculation was for over here? Yeah, equals 2. Okay, so at this point now, I've figured out what my checksum is. I've run the calculation on those first 9 digits. I've come up with what the check digit should be. Now I just have to figure out, is that what the check digit is? So instead of just returning false, now I'm going to return something different depending on the result of that calculation. We'll do that with an if statement. Again, next week we've got, actually we might do loops on Wednesday. Maybe we're doing this, loops are next Monday. But Wednesday is the if statement. We're going to get into great detail on conditional code. Here's a preview. If the checksum I just calculated is equal to the very last digit that was passed in, which is the rightmost digit of my candidate, what does that mean? If the checksum I calculated is equal to the rightmost one digit, is that a valid ISBN or an invalid? It's valid. Yeah, that's the whole idea, is that I calculate on those first 9, and so if that's the case, it's valid. True. Otherwise, it's false. So now I'm going to run this again. Get right to here. The checksum is changing. Are they equal to each other? They are, so now my function is going to return true, and it returns true. If this is a different check digit, like 3, it should return false. But with the proper check digit in there, then it's correct. Okay, how are we doing, folks? How many of you are going, this is so simple, can we please move on? If you're in that position, this class really isn't for you yet. That's okay. I'm not teaching to you yet. How many of you are going, I think I'm following this. There's no way I could have written it before today, but I think I'm following it. That's where I'm hoping that you're going to be. And anyone going, this is witchcraft. Okay, now, we have a problem here. And let's see what happens. First of all, is this going to execute still? Take off the breakpoint. Is this going to have an error, or will it execute? I think it's going to execute it. Yeah, it executes okay, but is this a valid ISBN? This is a valid ISBN. So why isn't it telling me that it's valid? Let's put a breakpoint here and run it. So my checksum right now is 10. See the problem? VBA doesn't know that X means 10, right? To VBA, X means X. Or, I mean, if you really had to give it a number, what would it be? 120. That's the number that the VBA kind of thinks of X as, not 10. And so, So if that's the case, it's true. Let's do this. Let's give ourselves another option right over here. So if it wasn't, well, we'll give ourselves another look. If checksum equals 10, special case, and the rightmost one character is equal to X, then else, and if, all right, so listen, folks, if the thing we calculated is the rightmost character, it's the same as the rightmost character, that's a valid ISBN, we're done. If not, well, there's a special case we want to check. If the checksum is 10, and the rightmost character is X, then it's true, and we're done. Otherwise, it's going to be false. I don't think we've got anything else that could possibly do that. This is a nested if statement. It's an if inside of an if. It's ugly. Humans can typically deal with it with one level of nesting in the if statement without too much trouble. We put a third level in there, and just get ready for the bugs to start happening, because it's tough for us to deal with that. You can do it, but you've got to be very systematic about it. Okay, so now that should run through, and it produces true. Let's run it again without the breakpoint. And that returns true. If I change any one digit, it should now return false. What if we capitalize the X? Good heavens. What do you think? False, yeah, because string comparisons are case sensitive. Now, there's a couple ways around this. What's the first thing I could do to make this string comparison not case sensitive?
Lowercase.
Option what? Option compare text. So when I tell the interpreter to make text comparisons between strings, it's going to ignore case. Lowercase x is equal to capital X. Oh, I hate this. I mean, if you really had to do a lot of stuff with text and it was really all not case sensitive, the problem with this is what if somewhere else in this module I want to do a case sensitive comparison? No can do. So instead of doing that, I heard someone else say another approach. What was it? Yeah, so there's a function called lcase. Lowercase. Whatever I give it, it gives me the lowercase equivalent. So I say lcase of capital X, and it gives me lowercase s. By the way, what's the lowercase version of 4? It's like 3.5. Well, it's still 4. There's no case to numbers, and so they're the same. But letters that have an uppercase and lowercase. And so this is the part that's evaluating to X or the capital X when we send in a capital X. And so I'm going to wrap right around that lcase function. Now remember when I said that a function returns the value that it calculates to where it's called. The same thing here. These are built-in functions. But now this right of candidate 1 is going to bring back a capital X. That capital X will get fed to the lcase function. And then this whole thing will return a lowercase x, and then the comparison will be lowercase x to lowercase x. Can we make long lines? It's a function, inside a function, inside a function, inside a function, inside a function. Yeah, you can go crazy. Knock yourself out. You probably want to knock yourself out once you've done that to yourself the first time. But before too long, you kind of get used to it. But when you do that, you're doing exactly the problem that you built for yourself when you made that long formula inside of an Excel. It's just this one long thing that you can understand while you're writing it. But it's tough to understand later. Okay, so now that for the capital X, that should return true as well, even though we got rid of the option base or the option compare text. All right, so far so good. What can we do to break this, to have this thing actually just die and not return a value at all? Any thoughts? Yes, what happens if I throw in one number less? Actually, let's do one number less up here. Let me get rid of this first 0. I think this one will still execute okay. It's not going to give me the right value, but it's going to run. Because in that case, it doesn't do anything illegal. In this case, I think it's going to be a problem. Get rid of one character, you get a type mismatch. I programmed for probably 8 years before I understood what a type mismatch was. What's a type mismatch? What does it mean? So right here, let's see what X is right now. X is 9. And so what is this? What does this value evaluate to right now? Come down here and just print it out. That evaluates to X. It's trying to take some number, 244, plus this character number X. Does it know how to do that? Actually, it does. Watch this. 244 plus x. There you go, 244x. The problem is, this part is getting evaluated okay. The problem is happening when I try to take that result and put it back here in a checksum. Let's just see what that whole thing evaluates. No, it still doesn't like that. So I guess it's happening before then. Yeah, the problem definitely is happening when I try to take 244x and put it back into this variable, because this variable is an integer variable. We can only take a number. Go ahead.
What about when it's being multiplied by 11 minus x?
Yeah, that's what's causing it, right? So if I was to take this and try to run it, this would fail. Because when we're looking at just this portion of it, this is okay because plus is meaningful for a string. If I take a string and say this string plus this string, or a number plus a string, it's okay, concatenation, I get it. But I'm trying to multiply a string by a number, and it says, I have no idea what you're talking about. So the type mismatch is actually happening right here. I've got a numeric, and I'm trying to multiply it by a string, and it's saying it can't do it. So, what should we do? Any thoughts? Go ahead.
Do we include an if statement to count the number of digits?
Yeah, that's great. Listen, if this thing isn't 10 digits coming in the front door, it doesn't matter what you've got here. It can't be right. After all, it's a 10-digit ISBN. So let's just do this. If the length of candidate is different from 10, then exit function. Oh, exit function is great. Exit function says, get me out of here. Skip everything else. Just jump to the end function here, and let's move on with life. So we'll skip everything else here. What will this function return if I don't tell it what to return? False. Returns false. So in this case, I haven't told it what to return. It's going to return false. That's great. So I'll stop that. I'll run this again. And it just tells me false. And that's what it should do, because it's not a valid 10-digit ISBN. It's only 9 digits for crying out loud. All right, that looks pretty good. Let's go back to 10 digits, but let's make the first digit an A. I'm going to have the same problem I had before, type mismatch, because now it's the right number of digits, but it's trying to add A onto checksum. And it's not happening. All right. Any thoughts on how we're going to deal with this? Go ahead.
Set the left 9 digits in whatever the string is as an integer. Let's say it has to equal an integer.
So what you're saying is, let's just ask for those last 9 digits and ask, are they numeric? Yeah, let's do that. So we can do this. If the left of candidate, the left 9 characters, turns out there's a function called isNumeric. You just ask it, hey, is this expression a number? It looks at it and says, could I make that string into a number? It's expecting a string, which we're giving it, and then it's going to look into a number. Is it a number? If it's numeric, then exit function. Wait a minute, that's backwards. If it's numeric, it's okay. So what, is there a function called isNotNumeric? Okay, watch this, folks. Stay with me on this one. This is going to return true or false. True. When it is numeric, it returns true. So I could say, if isNumeric equals true, equals false, then exit function. Right? Because if this evaluates to true, then this whole expression says what? Don't tell me what it evaluates. What does it say? It says true equals false, and that is false. There's another approach here. I'll write them both, and we'll vote to see which one I keep. We're going to vote one off the other. Not is numeric. These two are logically identical. If this returns true, this whole thing will say true equals false, which is false. If this returns true, this whole thing will say not true, which is false. Which one do you like better? Who likes the equals false better? Who likes the not is numeric better? I think the not is numeric should win. I'll leave the other one there for you just for kicks. Okay. I think we only have one more thing that we have to do to actually make this work. What's the one place that I could still have a problem? In the middle? Need a little more. The word function is right. The word end function is right. The problem is somewhere in the middle.
Last digit is not an X or a number.
Ah, that's right. We have validated now. We have validated the overall length. We have validated that the first 9 digits are correct. The whole thing's a number. But now I could get something wacky still in that last digit. So I'm going to say if the rightmost character of candidate, rightmost one character of candidate. Okay, so if it's not numeric, it takes a little bit of thinking. How are we going to do this? It's valid if it's a number. If it's a number, it's valid.
If it's not integer and not X.
Yeah, I think that's it. If it's not numeric and it's not an X, then get out of here. Okay, so if the rightmost one is different from, oh great, we got a lowercase in it. It's different from a lowercase x. L-C-A-S-E. And the rightmost one character not is numeric. Okay, so if it is a number and it's not x, that'll be okay. If it's an x, then it won't be a number for sure. If it's a z, it will be non-numeric and it will be different from x, and that'll get me out of here. I think that's right. So now let's change this back to a 1. Let's change this to a z. Actually, let's make sure it still works that way. That works. Change this to a z. Now that's no longer a valid number. Change it to a period. So I think we have successfully created an entire 10-digit ISBN validator here in class. It took us an hour and 15 minutes. Well, a little less because we talked about Frank Abagnale Jr. at the beginning. It's a little more complex through the 13-digit ISBN from the way I've defined it for you. That's the project that you have coming up. On the way, we're going to be talking more about loops. We'll get more specific things about loops, and we'll get some more specific things about the if statement and other conditional things that will both be helpful to you in working on that project. Questions? Thanks for coming, folks. Class dismissed. I waited until the applause was over before I stopped the recording. The vanity.
He's definitely having
Where is he recording?
Hey, that works. That's why I